Yes, hello, welcome to Trunkie Academy, guys. So we are discussing acid, bases, and salt. So in which we have in the yesterday's class we have started the pH concept, and in pH word, P stands for potence. The meaning of this word is potential or ability or capacity, and H stands for the hydrogen ion concentration. Okay, H stands for H plus ion or hydrogen ion concentration. H plus ion or hydrogen ion concentration, right? Okay, so this is the pH give the idea about the strength of the acids and strength of the base, right? Okay, now we have seen that the pH scale starts from 0 to 7 and then to 14. So exactly 7 is neutral. This is a pH scale. We have seen this part yesterday. Less than 7 is acidic, less than 7 is acidic, and greater than 7 is basic, right? So this is about the pH scale, right? Then I have also told you about, in the yesterday's class I have also discussed with you about the formula to find out the pH. pH is equal to negative log of H. pH is equal to just a minute. pH is equal to negative log of H plus ion concentration, right? Okay, then we have seen some questions for calculating the pH of the solutions, right? Okay, now that was for the pH. Now let us see some questions, some more questions with this concept. Just give me a second. Okay, just like pH is for acids, there is one more terminology called as pOH. Okay, so pOH is nothing but negative log of OH minus ion concentration. Okay, that means pOH gives you the idea regarding the basic strength, right? Okay, yes, so pOH gives you the idea regarding the basic strength. Okay, yes, now few things we have listed in the yesterday's class. pH is inversely proportional to acidic strength, which is also called as acidity. It is directly proportional to the basic strength, which is also called as basicity, and pH is inversely proportional to H plus ion concentration, right? Yes, and this was about the pH. Then about pOH also I can write down pOH is inversely proportional to basicity. Okay, basicity, that is basic strength. Basicity, it is directly proportional to acidity. And it is inversely proportional to OH minus ion concentration, right? And one more formula I will write down here to remember. pH plus pOH is equal to 14. Okay, this is also very important formula. Okay, yes, now you guys can just take a screenshot of these formula, all these pages, and then we will see a few more questions regarding the same chapter. Just take a screenshot, everyone. Whatever doubts you have, you can just let me know in the chat box. I'll just send a message in the chat box so that I hope you have taken a screenshot. Let us see the questions one by one. So first question I am going to write down now. Calculate the POH of okay. Yes, let us see how to do that. So POH is asked, and HCl, that is acid, is given whose concentration is 0.1, right? Okay, now as we know, in case of HCl only one hydrogen is present. Concentration of HCl is nothing but concentration of H plus, therefore it is equal to 0.1, right? So let us see, 0.1 is nothing but 1 divided by 10, therefore it is equal to 10 power minus 1 is the concentration, right? Okay, we know the formula for pH. pH is equal to negative log of H plus ion concentration. Okay, therefore pH is equal to negative log of 10 power minus 1. Okay, here one formula I have told you in the last class, as log of 10 power x is equal to x. Therefore log of this also will be equal to minus 1. Minus into minus 1 will become plus 1. So pH is equal to plus 1. By using pH I can find out the POH. Okay. Therefore, no, just a minute. As first of all, I'll write down the formula. As we know, pH plus POH is equal to 14. Therefore, POH will be equal to 14 minus pH, that is equal to 14 minus 1, that is 30. So what is the pH of this solution? pH of this solution is 13. Sorry, POH of this solution is equal to 13. Okay, so this is how we can solve the question based on the formula. Okay, yes, take a screenshot of this page. Okay, I hope you have taken a screenshot. Now after this, let me just upload one image over here, and that is for the pH paper. Just give me a second. Just a second. Okay, I hope you can see the image here. So this is the image for pH paper. Okay, so I hope you can see the image. So I'll explain this image to you. So this image is of pH paper. So what is the pH paper? If you remember, we have seen about the litmus paper or turmeric paper. So what are these papers? These are nothing but the indicators used to find out whether the given substance is acidic, basic or neutral, right? So in case of litmus paper or turmeric paper, we will get only qualitative result. That is, we will get whether the substance is acidic or not, basic or not. But in case of pH paper, we will get the idea about the pH range, right? That is, by using the pH paper, we will get whether the pH is like between 0 to 1 or 1 to 2 or likewise. So therefore, pH paper is really very important for determining the strength of acid and strength of or base also, right? So you can see different colors are there. So starting from red, orange, yellow to blue, right, and indigo. So these are the color. So first of all, I'll start from the bottom. So this is color for the NaOH, which is also called as lye. Next is for bleach, the household bleach, which we use, the bleaching powder, which we use many a times. Then next is for household ammonia solution. Its pH is in this color, this range 11 to 12. You can see the color. So then next is milk of magnesia, which is magnesium hydroxide. Milk of magnesia is used as an antacid to treat the acidity, whose pH range you can see here. Then next is sea water. Yes, before the sea water it's baking soda, whose pH range is 8 to 9, and about at 8 it is sea water. Sea water contains so many salts in it and so many different substances in it, therefore its pH is not exactly equal to 7. Okay, then it's blood tears, which is having the pH greater than 7. Then freshly distilled water, okay, freshly distilled, okay, so this is 7. Now but freshly distilled water I will explain later after this image. Then pure rain, it has pH in between 5 to 6. Then coffee 5, coffee is also acidic. Then orange juice, beer, acid rain, tomatoes, vinegar, lemon juice, carbonated beer, these are all acidic in nature. Their pH are less than 7. Stomach acid, the the juice which is present inside your stomach, which is used for digestion of the substances, that is having very low pH between 1 to 2. And then sulfuric acid or the H2SO4. that is having pH very less. So by using this we can find out the pH of the different substance, right? Okay, now what about distilled water and freshly distilled water? I'll tell you. So there is a difference in between these two. So for distilled water I'll use the word DW. Okay, D stands for distilled and W stands for water. Distillation process you have studied already in your class 9. And distilled water kept for some time, and freshly distilled water. Freshly distilled water means very fresh, right? So in case of freshly distilled water, pH is equal to exactly 7. In case of freshly distilled water, pH is exactly 7. Okay, pH is exactly 7. But in case of the this one, only distilled water, can you see here the only distilled water where it is? So yes, freshly distilled water is 7. But in case of only distilled water, pH is not exactly 7. It is little bit acidic in nature. Why this is so? It is less than 7, you can say. pH is less than 7. Okay, why this is so? What happens when we are distilling the water? And after distillation, immediately after distillation, its pH is exactly equal to 7. But what happens? The water, distilled water, okay, it combines with the carbon dioxide present in the this one, air. In the air, carbon dioxide is present, right? CO2 is nothing but carbon dioxide. So what happens? This water combines with the carbon dioxide and we get H2CO3. Okay, what is H2CO3? H2CO3 is called as carbonic acid. Carbonic acid. Okay, now as it is an acid, it is acidic in nature, right? And therefore, due to this acidic carbonic acid, the pH of distilled water after some time, it is less than 7, right? It is less than 7. I hope you understand that. Now this is about distilled water and freshly distilled water. Now let us see the fresh or pure rainwater. Pure rainwater. Pure rainwater, very highly pure, and the acid rain. Okay, and the acid rain. So for pure rainwater also, pH is exactly equal to 7, completely neutral. Nothing is there in it, only H2O. Nothing is there, no any other chemical is there. And whereas acid rain has the pH of about 5.5. Okay, about 5.5. Okay, so what is the reason for this? In case of pure rainwater, it is only H2O. Only H2O, right? Only H2O. No any other chemical is present. But in case of acid rain, some other things are there. What are these other things? Let us see. So first, I'll write down some reactions here for the acid rain. How the acid rain is produced. What happens? Rainwater come down from the top to the bottom towards the earth's surface. While coming down, that rainwater get mixed with some gases present in the atmosphere. There are some pollutants present in the atmosphere like carbon dioxide, nitrogen dioxide, sulfur dioxide. So this rainwater, while coming down to the earth, it get mixed with these different gases, different pollutants, and after mixing, it gets converted into the different acids. So that part I am going to tell you. So let us see one by one. So first of all, water, this is the rainwater, it get mixed with the carbon dioxide. All of these are the non-metallic oxide, get converted into H2CO3. H2CO3 is called as carbonic acid. Just give me a second. carbonic acid. Okay. Yes, now this is about the carbon dioxide. Now let us talk about the next acid, next gas, that is nothing but the sulfur dioxide, SO2. With sulfur dioxide also, it gets converted into H2SO3. H2SO3. H2SO3 is called as sulfurous acid. Sulfurous acid. So this sulfurous acid gets oxidized by the oxygen in the atmosphere and gets converted into H2SO4. H2SO4 is sulfuric acid. Okay, see the difference. Sulfurous acid is H2SO3, sulfuric acid is H2SO4. Right? Yes, these are the acids mixed in the atmosphere due to sulfur dioxide. Okay, then next is the nitrogen dioxide, NO2. It gets converted into HNO3. HNO3 is called as nitric acid. Now, due to all these acids which are produced by mixing of rainwater with the different gases, different non-metallic oxides like CO2, SO2 and NO2, these are all acids: carbonic acid, sulfuric acid, nitric acid. These are all acids, right? So what happens, that rainwater get mixed with these acids and get converted into acid rain, and therefore its pH is less than 7, right? This image of pH paper is already there in your textbook. You need to take a screenshot of it, but take a screenshot of other things in it. Okay, yes. Now after this we are going to discuss the importance of this pH in everyday life. Okay, yes. So as you know, in day to day life so many things we observe, just like I have given the example of acid rain here, right? So acid rain is an issue if it is not treated. For an example, if in the class 6 you have learnt about the Taj Mahal as a case study, like you know the Taj Mahal of Agra, which is a monument made up of white marble. Due to the acid rain, due to the pollutants released in the nearby area in Agra in India, it was started converting into the yellow. The marble started getting yellowing. So that's why all the industries, all the chemical industries in that area were further stopped by the Indian government. So this is the, you know, the effect of what you can say, importance of pH in day to day life, right? Okay, so the same thing we are going to discuss now, some other importance or some other things also. So and that is, I'll write down the title. Importance of pH in everyday life. Okay, yes, one by one let us see all these things. So first of all, the first is about the pH in our digestive system. pH in our digestive system. Okay, as you know, there is an acid, it is hydrochloric acid is present inside the stomach, which is also called as a stomach juice, or the acid juice present inside the stomach. So that helps us in the digestion of the food, right? But what happens sometimes, due to some like constipation or unhealthy eating habits, we have a excess of acid secreted inside the stomach, and then we say we have the acidity, or we I'm suffering from constipation, I'm not feeling well, likewise, right? So then in that case, what do? We take some medicines, like we take Rantac, then we take Omaze, we take Pan D, right? What are these? Or we take Pan 40. What are these medicines? These are, or we take milk of magnesia, milk of magnesia. What are these medicines, guys? These medicines are nothing but they are going to kill the effect of the excess acid created inside the stomach, right? Whenever the excess acid is created inside the stomach, that situation is called as hyperacidity. Okay, hyper stands for greater, acidity. When excess acid is created or secreted inside the stomach, that concept is called as hyperacidity. Now hyperacidity is treated by using these antacids. What are these? These are the medicines used to what you can say, neutralize the excess acid or kill the effect of excess acid inside the stomach. Therefore they are called as anti to acid antacids. Okay, anti to acids antacids. Okay, yes, antacids. So what are the antacids? Antacids obviously they are going to kill the effect of excess acid present inside the stomach, right? And therefore obviously as antacids are killing the acids, excess acid present in the body, therefore they are basic in nature, right? They are mild bases. Mild means what? not very strong, not very strong, very strong bases are not required. Mild bases enough. So mild bases are used for killing the excess acid created inside the digestive system, right? Okay, yes. So this is about first factor, and that is nothing but the pH in our digestive system. Then let us see the next one, and that is nothing but the pH sensitivity. Second point I'll write down. pH sensitivity. You know, animals and plants, they are sensitive to pH, right? Okay, so our body works within the range of pH 7 pH 7 to 7.8 is the pH required for human body, is the pH required for human body, right? Okay, that is the neutral pH. You can see 7 is nothing but the neutral pH. Okay, if any change in the pH, like for example, if pH is increased or pH is decreased, then the animals as well as plants are very sensitive to it. Okay, for an example, I have given the example of acid rain. Okay, acid rain is having the pH less than 5.6. Okay, acid rain has acid rain has pH less than 5.6. If the pH of the rain water is less than 5.6, that rain is called as acid rain. So that is also not good for the soil, for the animals, and for the non-living things as well as living things also. So these are the first two factors of importance of pH in everyday life. There are two more factors which we are going to discuss in the next class. So you can take a screenshot of this page, and then we will end today's class here. Take a screenshot. Okay, I hope it's done. Now that's all for today, and we are going to end the class here. So for today's class also, you will be able to see the DPP daily practice problems. Let me just show you to that. So again, so this is the teachers portal actually. So similarly, the student portal is also there. So you are going to just go to the resources, then to the work writing material, in which you will be able to see DPP, where you will download it, and then you will solve all the question based on it, and you are going to write down the solutions on a piece of paper, and then you are going to submit it in the portal, right? Okay, so that is the idea for the DPP daily practice problem. I hope you understood that, and yes, so that's all for today. In tomorrow's class, we'll learn the remaining points related to this particular topic, importance of pH in day-to-day life. Thank you so much, student, for your precious time, and all the best to you. Take care. Bye bye.